All right. So the way this works is I'll just be going through the questions. You guys are just like here to kind of observe how I do the questions. If you guys have any sort of questions or don't understand it, send a message or like just speak up. And I'll depending on the time, I'll go through it again. I think Doctor Yu wants this more to be like a observation class, not exactly fully revision, but yeah. Okay, so we'll start with question one. So, which of the following functions is differentiable? So the way you can do this is you can just graph all the functions and look at the point x equals 0. So you'll see that uh, immediately you can cross out y equals x to the power half because that's just this graph. And when you differentiate this, it's 1 over 2 root x. And when x equals 0, it's like infinity, the gradient, and that's undefined. So C can be rejected straight up. Y equals x to the power 1/3. The graph looks like this. And when you differentiate 1 over x to the power 1/3, it's also like undefined. So like you can't have like an infinity gradient and say it's differentiable. So that's rejected as well. Y equals x to the power of 2/3. This also doesn't work because if you look at the graph, it looks like the graph looks something like this. But a bit hard to draw, but it's very sharp like that, and the gradient is not 0 there. Because when you differentiate this, the gradient should equal 0, but it's a very sharp gradient here. Like what do you call it? It's like a cusp. So this is also rejected. But when you graph this, it's more parabolic, and the gradient can equal 0. So that's why D is the answer here. Uh, Question two is just pretty easy. It's just discriminant. So B squared minus 4AC. Two unique solutions must be larger than 0. So uh, the 16 minus 4 AC must be larger than 0. AC less than 4. For this one, you want at the infinite number of solutions. That means that the two lines must be the same. So a quick way we can do this is divide with the second equation, just divide everything by m plus 1. So then it just becomes x plus 3 over m plus 1 y equals 8 minus m over m plus 1. And then now you just have to equate all of them. So x should equal x. That's how it works. And then m minus 1 Uh, m minus 1 should equal 3 over m. Yeah, m minus 1 should equal 3 over m plus 1, and 2 should equal 8 minus m over m plus 1. So here 3 equals m plus 1, m minus 1. So m squared minus 1 equals 3, m squared equals 4. And 2m plus 1 should equal 8 minus m. This is the second equation. So uh, then it's just 2m plus 1 should equal 2m plus 2. So then it's just 3m is equal to 6. So m is equal to 2. And here this gives m equals 2, m equals negative 2. But you have to take the value of m, which allows the both to be correct. So it's just m equals 2. For this one, you can just do it a very in a very like quick sort of way. It's strictly decreasing, right? So and it's a cubic. So we know what a cubic looks like. It looks like this. So and it's a positive one, so it's basically just like this. So wherever it's strictly decreasing is from like here to here, and we know it's square brackets. So it can't be this one, it can't be this one, and it's square bracket, so it's B. And like that's sort of how you do it without doing any sort of calculations. Question 5. So average rate of change is equal to instantaneous. So this is just h of 5 minus h of 2 over 3 is equal to h dash x. And we just solved that quick. 1 second. That's x equals -1, x equals 3. Uh, okay, so we're given a function and we have to find the perimeter formed by tangent lines. So the way I do this is I quickly define this function and get the tangent lines. So the tangent line at x equals 0 is y equals 2x minus 1. And the tangent line at x equals 2 is uh, y equals 3 minus 2x. And then the final line is y equals -2. So if we just look at this real quick, the graph looks something like this is y equals -2, 2x minus 1. So these two lines will intersect. We can quickly solve for that, but through observation, it's just x equals 1. And subbing that back in, y equals 1. So they would intersect about here at 1, 1. And this is sort of the shape. So this is the triangle we need to find the perimeter of. We can see that this is isosceles because if you look at this -2x, 2x, so these two edges are the same length, and so we just need to find the distance of one of them. So this is 1, 1, and we need to find this point here. So that is 3 minus 2x. 3 minus 2x equals -2. X would equal, let's see. Actually, yeah. 3x minus 3 minus 2x equals -2. X is equal to 5 over 2, I think. Yeah, okay. So this is 5 over 2, and the point is, well, -2. So then we just use distance formula. So 1 minus -2 squared plus 1 minus 5 over 2 squared. That gives you 1 minus -2. Like root 9 plus 9 over 4. Something. And that is 3 root 5 over 2. So that means this length here is 3 root 5 over 2, and this length here is also 3 root 5 over 2. And then these two, the distance between here and here is, well, if this is 5 over 2 and the middle here is 1, then the half the distance would be 3 over 2. So the base is 3. So it's just 3 plus 3 root 5 is okay. Okay, for question 7, let A be the average value of a function for an interval, and there will be three different values of A which will give the same average value. All right, so first you want to find the average value function. So the average value here in terms of x is f of x for the interval a to 1 on 1 over 1 minus a. So put this into your CAS, and you will get yeah. Okay, so when you put this into your CAS, uh, okay, you'll get the function 3a cubed plus 7a squared plus a plus 13 over 12. So and the way the quick and easy way you can do this is graph it, and you get a function that looks like it just looks something like this. And now what you're looking for is the value of a, which will give the same average value. Uh, wait, no, you three different values of a. Oh, okay. So since you're looking for uh, three different values, where there's three different values of a which will give the same average value. So that happens like this. So then the highest point at which it can happen is here, sorry, not including, and the lowest point can happen is here. So what you want to do is find the maximum and minimum. And the way to do that is you just differentiate this and find the local maximum and minimum. So you let a dash a equals 0, and you end up with you'll end up with -7 plus or minus 2 root 10 over 9. And this is just the value of a, right? We want to find the average value. So you just sub these two values back in. And you're left with this. Because and you have to remember it's not including brackets, because if you include this point, when the line goes through it, it only crosses twice, not 3 times. Yeah. Okay, so question 8. This is actually a pretty difficult question because you can't solve for it on the CAS. Well, you can, but like not the normal way. So the way to do this, the way that I started off with was just by doing f dash x equals 0. But you'll find that it doesn't really work. So because though it's very like complicated. So the way to do this is you want to find where uh, f dash x is larger or equal to 0. So basically you want to find like a way where it's always positive, and that way there won't be a point of inflection. So what you can do first is uh, differentiate it twice, and then you'll end up with, after you factorize it, you'll end up with 9x to the power of 4 plus 6 bx squared plus 6x plus b squared. And you want to find where this is always positive and never equals 0. Because this is one of the factors of the whole thing when you double diff this. And the other factors will always be positive. So this is the only factor that could make it negative. So you need to make sure that this factor always stays positive. And what you can do is just differentiate this again and let it equal 0. So d over dx of this should equal 0. And then solve. Uh, solve this, and you also need to um solve for this. Solve for f dash x is equal to 0. And you end up getting like b equals 3 to the power of 4 over 3 over 4. And at that point, what you should do is just go and graph this and use your slider. So what I did is I subbed this value in, and I found that there was no point of inflection at this point. So that means this point had to be included. Therefore, I rejected this one, and I left this in consideration because 3 to the power 4 over, and then I rejected this one as well because this approximated to a decimal is 1.08. So it had to be this. And I believe that was the answer here. Yeah. Uh, yeah, okay. This question I will go through again at the end, because it's pretty difficult and I feel like I butchered the explanation. Okay, so question 9. This is a pretty standard. Find the domain of this. So the domain of S of x is 1 minus x must be larger than 0, so x must be less than 1. And you have t of x, you need to find t inverse of x. So t inverse of x here is just x minus 1 over 3 and cos inverse plus 1 over 2. So you can just chuck this into your CAS and use the domain function. The domain function gives you -2 to 4. So then you just have to find the intersection between these, and you're left with x must be larger or equal to -2, but x must be less than 1. So that is B. And that's it for the multiple choice. So question 1 of short answer. One sec, let me check the chat. Okay, question 1. You guys want question 1, E, F, 2D, 3, and all right. Okay, so question 1. You're given a function, it's just a log function. And you need, for part A, you need to sketch the vertical asymptote and label it with the equation. All right. So the vertical asymptote here is x equals 2 over 3. And that's pretty simple. And that's it. Find the rule and domain of the inverse function. So right, f of f inverse x with x. So That's f inverse x. And you need to find a domain of the inverse function. The range is just all real numbers, so the domain is all real numbers. Sorry, the range of the it, f of x is all real numbers, so the domain of the inverse function is all real numbers as well. So yeah. Okay, so part C, sketch the graph of the inverse function and label points of intersection with the coordinates. All right, so we can kind of do this even without like graphing it on our CAS. So x equals 2 over 3 was one asymptote. So for the inverse, the asymptote is y equals 2 over 3. So that's just like here. And it intersected about here. And then now we should go, now we should do f. Now let f of x equal x and solve for the intersection. So we are left with x equals 1 and x equals 11.42. So now we have the points. So x equals 1, that is right here. So they intersect at 1, 1 and 11.42, which is about here. So now we can just sort of draw the graph. Oh, oops, I've drawn y equals 2 over 3 wrong. Y equals 2 over 3 is here. So it looks something like this. Y equals f. Yeah. Look, that's insert. Yep, it's all right. So part D, write down an expression involving using a definite integral and larger area with line x equals 10. So x equals 10 is here. So the larger area is this. And this is, you just need to write down the expression. So the area is just the integral from 1 to 10 f of x minus f inverse x dx. And shade the required region. We already did this before. Well, you should sort of outline the region when you're actually doing the exam. Like they've been a bit picky sometimes, so you should make sure you're always like outlining like the edges like this for a shaded region. And find its area. So you just evaluate the area, and the area is 50.22 units squared. Right. The mean value theorem states that if a function is continuous with closed interval and differentiable under open C such that. All right. Part one is just find the average rate of change. So that is just f of 10 minus f of 1 over 9, which is ln 28 over 3. Find the x value where the instantaneous rate of change equals average rate of change. So you just let f dash x equal ln 28 over 3. And that gives you x is equal to 2 over 3 plus 9 over ln over 28. Find the x value where the instantaneous rate of change equals the maximum value of the rate of change from x equals a to x equals b. So f dash is equal to, and b is larger than a and b are integers. All right, so okay, the maximum value of the average rate of change, that happens that happens right here. So the maximum value of the average rate of change is you just want to find because it's integers, you just want to find the two integers where it increases the most. And since it's a log function, it happens like towards like as close as you can get to the asymptote. So it's between 1 and 2 right here because you can see it's increased the most right here. So in this case, A and B are 1 and 2 respectively. So you just want to solve for when f dash x is equal to f of 2 minus f of 1. Because it's 2 minus 1, and that's 1. So your value of x is then 2 over 3 plus 1 over 2 log e of 2. All right, use Rolle's theorem to explain why the average rate of change will never equal 0. So Rolle's theorem is that if a function is continuous on a closed interval and differentiable on an open interval, such that f of a equals f of b, then f dash x equals 0. And you want to explain why f of... Okay, so in this case, the function f is continuous, and it is also differentiable on the open interval. However, f dash of x can never equal 0 here. If that's the case, we can also conclude that f of a can never equal f of b, because without a turning point, a function cannot ever reach the same value again. Therefore, f of b, therefore f of b minus f of a cannot equal 0. Therefore, the average rate of change will never equal 0. Because for the average rate of change to be 0, f of a should equal f of b. And that's just how you explain this. Okay. Find the values of a and b. I think just put this into your CAS. So you end up with h of x is equal to 9 ln 15x minus 2 plus 1. So a is just 9 and B equals 15. By the way, guys, if you guys struggled with this question, there was an error in the question. This should be h dash 1 of x, not h1 of x. Otherwise, it's impossible. So when you're going to reattempt this question, make sure it's just h dash 1 of x. And it's actually just a pretty simple question. Then you just differentiate this and you just put this into a cas and you end up with you solve for x, by the way, and you end up with x is equal to 3k minus 1 over 3k. And you can just do the limit where k goes to plus or minus infinity on your cas as well. So when k goes to positive infinity, you end up with like infinity over infinity, which equals 1. And when k goes to negative infinity, it just ends up being negative infinity over negative infinity, which is also again 1. So the limiting value here is just x equals 1. Question 2. So the implied domain here is you just look at the separate parts. So x here must be larger than 0, larger or equal to 0, and x must be large. X must be x now equals 0 here. So the intersection of that is just x belongs to positive real numbers. Show that f of x has no x-intercepts. So for x-intercepts, f of x should equal 0. Therefore, a root x plus b x should equal 0. Multiply both sides by x. So you end up with a x to the power of 3 over 2 plus b equals 0. And x to the power of 3 over 2 should equal negative b over a. Now, x to the power of 3 over 2 is always a positive number, while negative b over a is less than 0. Therefore, x to the power of 3 over 2 cannot equal negative b over a. Therefore, no x-intercepts. Consider a case where a equals 1, b equals 1. All right, so then f of x equals root x plus b 1 over x. And you just solve for the turning points. So you just differentiate it and let it equal 0 to find the x value. Which is x is equal to 2 to the power of 2 over 3. Show that the turning point is a local minimum. So just differentiate f dash x. You don't need to write this down, but uh, x equals 2 to the power of 2 over 3. That approximates to about 1.6. So then we can take x equals 1 and x equals 2 and put that into the gradient function. So f dash 1 is less than 0 and f dash 2 is larger than 0. Therefore, the turning point is a local minimum. I actually also just put in like write the actual value down as well. So f dash like 1 equals -1/2, which is less than 0. And f dash 2 is equal to root 2 minus 1/4, which is larger than 0. Determine the exact value of the y coordinate of the turning point. So you just sub in the x coordinate here and you get 2 to the power of 1/3 plus 1/4 to the power of 1/3. So, what is the equation of the vertical asymptote? That is just x equals 0 here, because b over x, or 1 over x. And now, using addition of ordinates, sketch this graph. You just need you can sketch this on your CAS, but it's a pretty simple graph. So first the asymptote x equals 0. And since we're using like addition of ordinates, just draw out both the parts sort of. So root x looks just something like this. 4 is here, 2 is here, so it just looks something like this. And 1 over x looks like this. 2. Yeah, so those are the two graphs there. And since you're adding them together, so 2 will be here. Yeah, two is here because but they're both 1 here, so it adds the 2 here. And then we also need to make sure we remember the endpoint. So g of 4 is 2 plus 1 over 4, which is 9 over 4. It's around 2.25. So it ends about here. So 4, 9 over 4. And we need to remember the turning points. So the y value is approximately around 1.9, and the x value is about 1.6. So the turning point is at about here. Yeah, here. So this is the turning point. So 2 to the power 2 over 3, and to the power 1 over 3. So the graph just looks something like that. And that's it. Yeah. So under what conditions will the turning point of f of x always occurs at x equals 2? So f of x is the original equation with a and b. So f dash x is the diff of that. So it's 1 over 2 a over 2 root x minus b over x squared. And the turning point, so you let it equal 0 minus b of x squared. Yeah. So you let this equal 0, and actually, sorry, always occur at x equals 2. So that means f dash 2 should equal 0. So let's sub in 2 here. So a over 2 root 2 minus b over 4 should equal 0. So let's multiply everything by 4. So then it's a root 2 minus b equals 0. b equals a root 2. And this is the condition that they're looking for. And question 3. All right. Show that the curve, okay, so you're given the function, and show that the curve crosses the x-axis between x equals -1 and x equals 0. We can see that has happened here. So this is -1, this is 0. The way to do this is just show that one x like f of -1 is less than 0 and f of 0 is larger than 0. Therefore, and because it's continuous, uh, as it is continuous, um, f of x crosses between. That's literally just it. Oh, I actually just also show the values. So f of -1 here is -11/12, and f of 0 is 1. Part B, Newton's method. So an estimate of one of the roots is -½ Use 2 iterations of Newton's method to find a more accurate estimate. So you just use, sorry, so you're given x0, which is -1/2, and you just use the Newton's method formula, which is x1 is equal to x0 minus f of x0 over f dash of x0. You just chuck this in your CAS, and you end up getting x1 is equal to -0.5792 for decimal places. And do this again for x2, and you get -0.5778. And that's it. Okay, show that f is strictly decreasing for all values of x. Okay, so strictly increasing means that there is no turning point. So let's differentiate f of x. So f dash x here is x cubed over 8. Sorry, x squared over 8. X squared over 8 minus 3 over 4x and plus 3 over 2. And you want to find where there's no turning points. So just use this discriminant here. So delta x should be less than 0 because you don't want any turning points. Um, so uh, delta x should be less than 0. Oh, sorry, let's just find delta x. Delta x is equal to -3 over 4 squared minus 4, 1 over 8, 3 over 2, which is 9 over 16 minus 3 over 4, which equals -3 over 16, which is less than 0. That means f dash x equals 0 doesn't have any solutions. Therefore, and you have to also remember, f of x, f dash x When x is equal to 0 is equal to 3 over 2, which is larger than 0. Therefore, uh, f of x is strictly increasing. Explain why f of x equals 0 has only one root. This is just because f of x is strictly increasing uh, for all x belongs to R, and um, yeah, no, that's literally just it. You can also say before it says that it crosses the x-axis between -1 and 0, but that's like unnecessary. Sketch the graph of f inverse x equal. So that is just you can just do this by observation. So um, this point here is -2, -4, so that means it goes through here, and it should cross somewhere around here, there, and then so -3, -8 is a point. So -8, -3 is also a point. So it looks something like oh, oops. That, and that's what I suppose f inverse x looks like. So now we're told find the area enclosed by f and f inverse x. So that's just did this. And a quick way we can do that because you're finding areas between inverses. Just do just find the area. Or first find the points. So just do f of x equals x, and to solve for the points of intersection, and you'll end up with x is equal to -1.05932. X is equal to 3.40441, and x is equal to 6.65491. And then you can see that this area here is actually a mirror image of this area here. So instead of find the integral of f of x minus f inverse x, you can just do for this part 2 times the integral of f of x minus x. And for this part, you can do x minus f of x, because f of x is lower part here, and this is x, and then find the integral of that and times that by 2. So that's what we will do. This way we can just avoid finding the inverse. Like it just saves a bit of time. So the area here is -1.059 whatever to 3.404 f of x minus x dx plus the integral from 3.404 6.654 of x minus f of x dx, and the whole thing should be multiplied by 2. And we get the area of 9.7 to 1 decimal place units squared. And that's the last question of this. All right. If you guys have any questions of the short answer, could you guys send a message or just speak up? Uh, you will get you can access a recording of this because I'm recording this. Pavan, yeah. Um, does anyone have any questions with the short answer for the part you just did? Why did you x minus f of x and not f of x minus x? So you mean this part, right? Because if you look at this graph, right, this is a different color. Um, this is the graph of f of x, right? And you can see f of x is actually the bottom one here, and this is y equals x, which is above. So and because it's the bottom area we're using, not the top area here. If you do f of x minus x, you're going to end up getting a negative area because um, f of x is the bottom function, not the top function. Because f inverse x is the top one here. Ravinia, did you understand that? I can redo it if you want. Question 1E. Okay. All right. So one, oh, this one. Okay. So, okay. So find the x value where the instantaneous rate of change equals the maximum value of the average rate of change. So the first thing here is there's average rate of change and there's instantaneous rate of change. And it says you want to find um, the maximum value of the average rate of change from x equals a to x equals b. So let and the key point is okay. The key point here is a and b belong to z plus. So that means they're positive integers. So if we look at this graph here, right? A and B are positive integers, and you want to find where the maximum value of the average rate of change occurs. The average rate of change is just f of b. This is the average rate of change, right? So we want to find where the maximum value occurs, and that happens where uh, the function increases the most within two integer values. And we can see, and we just have to look at the graph, and we can see that between like nine and 10, this point here, the function has only risen like a tiny bit. But between x equals 1 and x equals 2, so right here, we can see that the function has increased a pretty large size. And that is the largest it has risen over the course of the whole domain. Because we're looking at positive integers, right? And 0 is not a positive integer, so you can't take 0 to 1 here. So 1 to 2 is where the function has increased the most. What's the question? Wait, do you understand now why I use 1 and 2? Matter? Not really. Okay. Wait, okay, I'll just draw it then. Okay. So it's asking us here, the maximum value of the average rate of change of f. So the function looks like this. And you want to find where the maximum value of the average rate of change is. And the 2 points you're using are A and B. B is larger than A, and they're both positive integers. So in the graph, right, uh, the maximum value of the average rate of change occurs when the function increases the most. Uh, and you can see that since it's a logarithmic function, it's increasing the most over here. Like you can see that the rate of change here is way larger than the rate of change here. Do you get that? You can see that the rate of change is actually decreasing as you go further and further. So that means that the maximum average rate of change occurs at the very start or as close as you can to the start. And when you look here, it's the same case here, right? So the maximum average rate of change occurs in this region here. And A and B, which are the values, which are the points you're using, are positive integers. So what are the positive integers here? There's one, and then there's two, and then there's three here, I guess. But you can see that from 1 to 2, the function has increased the most, and 2 to 3, it's increased less. So it's increased the most between 1 and 2. Therefore, in this case, A is 1 and B equals 2. And we use that average rate of change from 1 to 2. And that's how we get the second part. And then now we just equate this to the instantaneous rate of change, and we solve for x. Uh, yeah, you need to inspect the graph for the values of A and B. Yep. Could we use values more than one for A and B and still get the same answer? What do you mean more than one? No, you wouldn't. You get something else because you could see that A and B are defined here as positive integers. So you need to use one here. Like, I think that makes sense. Yeah. Does anyone have any other questions from the short answer? How do you know if it is exactly 1 and 2 when inspecting it? Well, the thing is, it's not like you're not making an estimate here, right? You're just we know that a logarithmic function increases the most at the very start. So you want to get the smallest possible values. Yeah, sure. I'll explain that question after. How do you know how do you know if it's exactly 1 and 2? Well, you're not making an estimate here. You're just finding the smallest possible positive integer values, and that is 1 and 2. Because integer wise, um, it has increased the most from 0 to 1. However, 0 is not a positive integer, and A and B are positive integers. And that means it just has to be 1 and 2. There's no estimate here. Um, could you please explain 1D again? This is how we find limits on the CAS. Wait, 1D? 3D. Okay. Um, wait, 3D. That's 2D, right? explain why f of x equals 0. Wait, do you mean like 2D or something? No. How we find limits on the CAS. Wait, this one right here, right? F of x equals 0 has only one root. Oh, it's just that. Okay, so the function here is just like this, right? Like that. So we can see that it's strictly increasing. We prove this in part C. So if a function is strictly increasing, that means it will only have one root because that means it's only going up. So that means it will only cross the x-axis once. So say if a function is strictly increasing, and I guess we can also write previously, like in part A, f of x crosses the x-axis, and that it's strictly increasing. That proves that it only has one root. What do you mean by limits though? How we find limits on the CAS? Oh, you just mean like in general. Okay, so do you use a TI Inspire? Just click menu for four, and then you get the limit thing. The leftmost uh spot is you put like X or the value that's being limited, and then the right one, the very right one is the function, and so it'll be like X arrow infinity, and then you put the function into the big one, the big brackets, and that's just how you use limits on the CAS. Next question. 2D conditions for the turning point. This one. It's a very vague question. I thought there was more to it, but you just have to find some condition that makes this turning point always occur at x equals 2. And the only way you can do that here is um, by making sure that f dash 2 equals 0. And that's literally just it. Because you can't find the y coordinate. Like there's no condition for the y coordinate here. So this is the only condition that's possible. And that's how we come to this conclusion. This is a very vague question. Like I feel like there should be more to it, but that's literally all there is to this. All right. Does anyone have any question? Wait. So it could be technically done in terms of A as well. Yeah, you can also write A equals B over root 2 or something like that. Since there's no like there's nothing said about like do it in terms of A, do it in terms of B. You just write it like this. This is not a like VCA exam, so um that's why it's like this. But on a VCA exam, they'll definitely like specify more clearly. So yeah. Does anyone have any other questions with the short answer? No? Okay. Then I'll do question two because someone asked me this one. Okay. So question two was just the equation will have two unique solutions. So this is just a quadratic. So we can just use the determinant here to see when it will have two unique solutions. So two unique solutions means that the discriminant must be larger than 0. and the discriminant is b squared minus 4ac. So it's 16. So wait. So b is this. So 16 minus 4ac, and that must be larger than 0. And that simplifies to AC must be less than 4. And yeah, that's just how you do this. Um, does anyone have any other questions before I redo question 8? Wait, does someone want something else? With question 1 MCQ, isn't it the graph with no endpoint? Uh, the graph with no endpoint. Yes, but all of the graphs, only C has an endpoint. The other ones all don't have endpoints. Like, like if you graph all of them, C looks like this. X to the power 1 over 3 looks like that. Uh, X to the power 2 over 3 looks like that. And X to the power 4 over 3 is the only one that sort of has like a parabola shape. Like, isn't A continuous though? Um, it is continuous, but oh, sorry. The reason A is rejected, right? Is because the gradient, the gradient of A, oh sorry, well, if y equals x to the power 1 over 3 is actually 0. It's actually a stationary point of inflection. It's like this. Let's grab that. Like it's actually 0 here. But when you differentiate this, you end up with like um x, like 1/3 x to the power of -2 over 3. So like, and when you substitute x equals 0, it doesn't, dy on dx does not equal 0. Does that make sense? Try graphing in your CAS. So no stationary point. It's a stationary point of inflection, I believe. So yeah, so on like if you graph this, right, you'll see that a tangent to this will actually be x equals 0 because the gradient at that point is 0. But but the thing is, it's not differentiable because when you substitute x equals 0 into the gradient function, you can't get dy on dx equals 0 because it's 1 over 3 x to the power 2 over 3. So it's like 1 over 0, which is like infinity undefined. So no gradient at that point. Yeah, it's not differentiable at that point. Like the gradient when you graph it is 0, but it's not differentiable. You can't find the gradient by differentiating. And that's why we have to reject A. and then C is rejected because endpoints, and B is rejected because like it's like very sharp here, and that like that's not a differentiable point. And but D is like kind of parabolic, so it works. And you can also see that dy and dx is equal to 4x to the power 1/3 over 3. And when you substitute x equals 0 in, dy and dx equals 0, and that makes sense. Does anyone have any other questions other than question 9, multiple choice? Sorry, question 8. Yeah, other than question 8. Question 7. All right. Okay. So A is the average value of this function. And over the interval a to 1, where a belongs to negative infinity to 1. Uh, and you need to find where there will be three different a values for the same average value. So let's start by working out the average value. So the average value is 1 over 1 minus a, 0 to 1, of f of x, d of x. And just put this into your calc to like expand it. And you'll end up with what I wrote here before. 3a cubed plus 7a squared plus a plus 13 over 12. So now you have this in terms of a. And what you can just quickly do, right, is just graph this function. And the graph looks something like this. And now you want to find the average values which have three different a values that can produce them. And the way you can do this is finding where there's three intersections with the graph. So if you look here, right, that line intersects three times. That means there's three different a values that can produce the same average value. So we can keep drawing these lines until this point here and this point here. So this is the maximum average value, and this is the minimum average value. So the way to do this, the way to work out these values is just to find the maximum and minimum via differentiation. So just do a dash a is equal to 0, and you get a is equal to, I wrote it down before, -7 plus or minus 2 root 10 over 9. So that means the a value here, the a value here is -7 minus 2 root 10 over 9, and the a value here is -7 plus 2 root 10 over 9. However, the question isn't asking for the a value, but the average value. So you need to sub it back in. So you need to sub this back into this. And you end up getting a is equal to this, oh, sorry, this and this. But however, so it could be A or C now, because these are rejected now. And the only difference between them is the square brackets and the round brackets. So, but if we go back to our graph, remember, you cannot, what is this? If we go back to our graph, we cannot include this point. Sorry, it's lagging a bit. 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 So if you look back here, right, there, we it's round brackets we're using here because when you draw the line through this point, it will only intersect twice, not three times. So there isn't three different values of A for that average value. Therefore, we have to use round brackets here because we're not including the maximum and minimum points. Therefore, the answer is C. Does that make sense? This worksheet was tech active. A lot of the questions can be done tech free, but questions like this, you need to do tech active. These questions were taken out of exam twos for methods. So yeah, they're tech active. Does anyone have any other questions other than question 8? No. Okay. So I thought about this a bit more, and it's actually much more simple, right? Because all of these have the same value technically. Because 3 to the power of 4 over 3 over 4 is approximately 1.08. So now that we have this value in mind, all we have to do is just graph the function, letting b equal 1.08. Let b equal 1.08. And then we can just use the slider to find which of these is the correct one. So when you let b equal 1.08, you'll find that the function has no points. So that means this one, and this one are all rejected because they don't include b equals 1.08. So it has to be A. Does anyone have any other questions or want me to explain how I got this for question A? How to get the slider to have decimal? It's only whole numbers. Um, really? I do you use a Casio Cas? Use TI. All right. I don't have this problem. Wait 1 second. There should be a way to change the settings. So, I think, let me see. Does anyone have any other questions while I'm just finding out how to fix this real quick? Oh, okay, okay. So go into your click menu, actions, menu one, B, and then you'll find like slider settings, and then there should be something that says like display digits, float three. You can I think you can change that, and that will increase the number of decimal places that you can put in. Mine says float three, and I'm able to put in two decimal places. Just let me know if that works. Does anyone have any other questions? It works? Okay, that's good. Does anyone have any other questions on these? If there's no other questions, then you guys are free to leave.